Day 4 of learning about dramatic space. From the tiniest particles to the vast galaxies, everything in the universe is in motion. But what if I told you that the universe itself is expanding? This discovery has not only transformed our understanding of the cosmos but also raised profound questions about the fate of everything we know. Edwin Hubble, the Hubble telescope, and distant galaxies. It all began with the pioneering work of astronomer Edwin Hubble in the 1920s. He observed that distant galaxies were moving away from us, and the farther a galaxy was, the faster it was receding. This relationship, now known as Hubble's law, provided the first direct evidence that the universe is expanding. Hubble's law can be expressed as, the velocity at which a galaxy moves away from us is proportional to its distance from us. This is represented by the formula, v equals h times d. Here, v is the velocity of the galaxy, d is the distance to the galaxy, and h is the Hubble constant, the rate of expansion. V equals h times d, h equals 70 km per second, mpc, approx. Recent estimates place the Hubble constant at around 70 km per second per megaparsec. This means for every megaparsec, or about 3.26 million light-years, the velocity increases by 70 km per second. But even with this constant, there's still much debate and refinement ongoing. But what does this expansion mean for the future of the universe? There are three main possibilities, each depending on the overall density of matter and energy in the cosmos. First, the Big Freeze or heat death. If the universe continues to expand indefinitely, galaxies will drift apart, stars will burn out, and eventually, all matter will cool down to near absolute zero. The universe will become a cold, dark, and lifeless place. Big Freeze, heat death. Alternatively, if there's enough mass in the universe, gravity could eventually halt the expansion and reverse it, leading to a big crunch. In this scenario, the universe would collapse back in on itself, potentially leading to a new Big Bang, Big Crunch. But there's also a third possibility, the Big Rip. If dark energy, the mysterious force driving the accelerated expansion of the universe, becomes dominant, it could eventually tear galaxies, stars, and even atoms apart. Big Rip. Return to space visuals, emphasizing the scale of the universe. Which of these futures will come to pass? That remains one of the biggest questions in cosmology. What we do know is that the universe is a dynamic, ever-changing place. And while its ultimate fate is uncertain, our journey to understand it is far from over. Fade out with the night sky and distant galaxies. So, as we gaze at the stars, we're not just looking at distant lights. We're peering into the vast, expanding universe, pondering the profound mysteries of existence itself. Subscribe and follow for more space content.